Hey ladies, so today you guys have your quiz today. So here is a practice problem. This one's from your first section. I figured this one was probably one of the more tougher ones, especially since you're going to be manipulating a complex expression. So this one here, here we need to find the non-permissible values of the given expression, then we need to simplify it. And I apologize, my Microsoft Word is for whatever reason not working, so we're using Paint. So hopefully it's not too different, but I guess we will see. Okay, so first of all, we need to find our non-permissible values here. So start off with A here. So you have to find the non-permissible values. And to do that, you have to think about when would this function be undefined. So your biggest thing that you're looking for is when will there be fractions. Because whenever we have fractions, we can have 0 in the denominator. And when you have 0 in the denominator, that is when you're going to have undefined functions. So the big keyword there is when you're looking, so it's some number divided by 0. So any case where this will happen, okay? So then you go and compare each of the functions. If it were just numbers, obviously you don't need to. You can obviously just tell, well, if it's 1, 2, or 3, or any number that's not 0, it should be fine. So there's that for you guys. Okay, so your first function you're going to look at, let's look at secant squared of x. And that one, we can rewrite this as 1 over cosine squared x. And here we have a fraction where if we had cosine squared of x, that one can be equal to 0. So we want to look at when this denominator here would be equal to 0. So at that value, that is where it's going to be a non-permissible value. So we can rewrite this as cosine squared of x is equal to 0. And then we can rewrite that as cosine squared, or cosine times cosine of x is equal to 0. Then we just have to look at one cosine, because either way, they're both the same thing. So if you get one for one, you'll get it for the other. So when does cosine of x equal 0? So from there, you can use your unit circle. You guys can solve it. Using your unit circle, you guys would see there's a general solution of pi over 2. It could also be at 3 pi over 2, and so on. And it doesn't really define any of our values here. And I also didn't define whether or not it's in radians or degrees, and so let's just use radians. That'll be fine. So x cannot equal, and we'll do our general solution. So there's that little nice I guess pattern there of when you're at pi over 2. Then you add multiples of pi, so it'd be pi n, where n is an element of integers. Okay. So there's your non-permissible value for secant x squared. Okay. So next one we can look at here is our cosine of x here. That one, at cosine, there's never any undefined values, so we don't have to worry about that one. If it was in the denominator, then we would totally have to, but because it's in the numerator, we don't have to worry about it. Okay? So then your next one you want to look at is the cosecant of x. It's in the denominator of the fraction, so we definitely want to look at that value there. Okay? So here we'll write cosecant of x is equal to 0. So when is that value equal to 0? That we can rewrite as 1 over sine of x is equal to 0. And there we can look at when does that sine of x equal 0. Alright, so from there we're going to look at, so what values of x are going to make sine of x equal to 0. And that you guys would find your x, and we'll say it cannot be since we're looking for non-permissible values. That one is every time x is equal to pi, 2 pi, 3 pi, and so on. Okay? And we'll write that general solution there. So here we have x cannot equal to pi plus any multiple of pi, which would be pi times n, where n is an element of integers. Okay? So from there, we could either leave it like this, but what we can do is that we notice a pattern that we can go from pi over 2 to pi up here. Then we can go to 3 pi over 2. Then we go to 2 pi. So from there, if you notice that every time you add half of a pi, we get those non-permissible values there. So here we could say that x cannot equal, so this one's kind of like an overall sort of statement. So x cannot equal pi over 2 plus any multiple of pi over 2n. where n is an element of integers. Okay? Alright, so that is for finding our non-permissible values. Now what we need to do is we need to simplify the given expression. And I'm just going to pause this here and clear this away, so make sure you quickly write all this down, and then, well, I'll quickly pause the video, clear it, so, or I guess you guys won't notice I pause it, so there we go. Alright, so for B here, to simplify it, what we're going to look at mostly is we're going to flip these back to the I guess our usual three primary trigonometric functions, and simplify it that way. So first off, let's go with secant squared of x. That one, if you guys remember, that one is the reciprocal of cosine, so we'll write cosine squared of x. Times that by, we'll leave cosine as it is. That one's already in that kind of form there. And sorry, this should be multiplying here, so it looks kind of sloppy there, but it'll be 1 over cosine squared x times cosine of x. And then let's change this cosecant of x, and that one, if you guys remember, is the reciprocal of sine of x. Okay, so from there let's simplify. So here we can rewrite, if you guys remember your fractions, you would multiply cosine of x, multiply with 1, so we're left with cosine of x, divide that by cos squared of x, and that's all divided by 1 over sine of x. From there we can cancel out here, we have cosine of x, and we can cancel out that little squared there. So we have 1 over cosine of x. We can say divide that by 1 over sine of x. I'm just going to rewrite this like this. Divide that by 1 over sine of x. And then we can use our division here, or our division rules there, so we can rewrite that as 1 over cosine of x. Remember, you change the sign and then flip your fraction. So you're multiplying sine of x over 1. And then that finally is equal to sine of x. Divide that by cosine of x. Then that is equal to, and if you guys remember, what is sine x over cosine of x? Well, that is just tan of x. Alright, so from this we can say that secant squared of x times cosine of x, all divided by cosecant of x, is equal to tan of x. So simplified, that is simply what it is equal to. So here we looked at a really, really complicated expression and we made it simple. Alright, so there you guys are. Whenever you guys are ready, quickly do your cheat sheet, then the quiz will be on my desk there for you ladies, okay? Hopefully this helped out, and let me know how it goes.